What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at day 2 of 6.6, applying scientific notation. We're going to do a lot of real world problems, more so looking at our word problems for this one. Our first one is this. The diameter of the sun is 1,400,000 kilometers. The diameter of the earth is 1.28 times 10 to the 4th kilometers. How many times greater, which means we're probably going to need to divide, is the diameter of the sun compared to the diameter of the earth? So that means we're going to have to take the sun's diameter and divide it by the earth. So let's start with that. The sun's diameter is 1,400,000, but we're going to go and write that in scientific notation. So that's 1.4 times 1, 2, 3, 4, 5, 6 over earth is 1.28 times 10 to the 4th. What I know I can do here is subtract my exponents. So I'm going to get 10 to the second, and then I'm going to divide 1.4 by 1.28. Oops, 1.4 divided by 1.28, and I'm going to get 1.09375. So 10 to the second just means I can move that decimal 2 times, so I'd get 109.375, so I can just round it and say about 109 times bigger. Okay, our next one also talks about comparing. A dime is 0.125 centimeters thick, and a dollar bill is 1.0922 times 10 to the negative second centimeters thick. How many times greater is the thickness of a dime than a dollar bill? So again, dime divided by dollar. So we'll start with that. 0.125, let's put that in scientific notation. That'll be 1.25 times 10 to the negative first over 1.0922 times 10 to the negative second. Okay, what we'll do is then divide my numbers. So we'll start with that 1.25 divided by 1.0922, and I'm going to get 1.14447903. I'm just going to stop at that one. Times 10, and then with this I'm going to subtract -1 minus -2, which is actually -1 plus +2, so times 10 to the first. So when I solve this, I'm going to take that number, 1.1444 times 10 to the first would give me 11.444. So we would say about 11 times greater. Okay. The area of a rectangle is 5.612 times 10 to the 14th. The length of the rectangle is 9.2 times 10 to the 7th. What's the width? So to find that, we would need to take area and divide by length to see what our width could be. So we can take 5.612 times 10 to the 14th and divide it by 9.2 times 10 to the 7th. Right away, I know I can go ahead and place my subtraction of exponents. That's 10 to the 7th. And then the next thing I can do is take that 5.612, divide it by 9.2, and I'm going to get 0.61 times 10 to the 7th. So with that, I would just take my 0.61 times 10 to the 7th, but I do want to make it into scientific notation. So you can do one of two things. If it's helpful for you, take 0.61 and move it 7 times to the right. 1, 2, 3, 4, 5, 6, 7. Fill those empty spaces with zeros, and then decide where your new decimal should go. Here at 6.1, and that's 1, 2, 3, 4, 5, 6. So that'd be times 10 to the 6th. Or we know that if we have to scoot to the right, we subtract the number of times we have to scoot to the right. So since I scooted to the right once, I subtract 1 from 7, and that is how I got my 6. Okay? Going onward to this one, the Oort cloud is a spherical cloud that surrounds our solar system. It is about 2 times 10 to the 5th astronomical units from the sun. An astronomical unit is about 1.5 times 10 to the 8th kilometers. So how far is the Oort cloud from the sun in kilometers? In this case, we would need to multiply the size of an Oort cloud with how far that is surrounding our solar system. Okay, so we're going to end up multiplying these two items. First thing we probably need to do is multiply our two numbers. 2 times 1.5 is 3, and then we would add our exponents to get 10 to the 13th power. When we do that, it's also going to create a huge number. So that's 3 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros. A big number. 1, 2, 3, 1, 2, 3. There. Okay. And then our last one before we're finished up with this one, it takes the sun about 2.3 times 10 to the 8th years to orbit the center of the Milky Way. It takes Pluto about 2.5 times 10 to the 2nd years to orbit the sun. How many times does Pluto orbit the sun while the sun completes one orbit around the Milky Way? Write your answer in standard form. So we're just comparing the sun to Pluto. So how many times can Pluto go into the sun? So dividing. So we'll take the sun at 2.3 times 10 to the 8th over 2.5 times 10 to the 2nd. We're going to divide 2.3 by 2.5 first. And we're going to get 0.92. And then subtract my exponents. I'm going to get 10 to the 6th. And then I'm just going to write out this number. So 0.92 times 10 to the 6th. And my decimals here, I'm going to go to the right. 1, 2, 3, 4, 5, 6. Or 920,000 times. Okay. That'll conclude our lesson on 6.6 day 2. This is just applying those operation rules for scientific notation. Hopefully this video helped you, and we will catch you next time when we do our big chapter 6 review. Have a great day.